Is this good? Good? Is the screen good? Okay, cool. I'm running behind already. All right. Whoops. Are you ready for me to go? Okay, cool. Hey everyone, my name's Mark Allen, and I'm here today to talk to you about Git and Python and GitHub. And what I'd like to do to start with is just kind of get a sense for what the audience is like. How many of you are already using Git right now? Okay, great. And how many of you have used something else, like Mercurial or SVN or Perforce or God help you, SourceSafe or something like that? Okay, so a lot of people are familiar with the idea of version control and what it's all about and why it's a good idea. Usually I give this talk on a screen that's about as tall as I am. So in those talks, what I do is I usually run around the room and point at things on the screen. This screen is like super nice, and the projector here is like ridiculously awesome. So I'm not going to be able to run around as much, but I have this thing. I don't know if I'll probably blind myself. Well, it doesn't seem to be working. But all right, so I'll just do the best I can, and hopefully if there's any questions, just ask me. So if there are questions during the talk, just ask me. Usually what other people in the room are thinking the same thing. So let's just have that as our initial ground rules for what we're going to do here today. So Git is a distributed version control system. It's just a bunch of words on a slide. What does it mean exactly? Basically, it means that when you use Git, you're getting an entire copy of the source tree. You're not getting like a little tiny piece of it or your own little fork of it or whatever. You're getting the whole entire history of the project from the point of view of wherever you got it from. And that's pretty cool. That lets you do all sorts of interesting things, some of which we're going to talk about today and some of which we probably won't have time to. But it's fast, and it does have tons of features, and it really is pervasive in the Python community. I know a lot of people here also use Bitbucket. That's fine. I'm not dogmatic about what version control system you should use. I like Git, and there's a huge development community on GitHub, so that's why I use it. But it does have a pretty broad audience, and it has the worst interface ever. It really does. It's absolutely not written for human beings. And the documentation, as some of you probably know, is really bad. That's very unfortunate, because it really is a nice piece of software if you can kind of look past its warts. So we're going to talk about terms and lingo. We're going to kind of go through a basic workflow. I have a slide that's coming up that kind of has a side-by-side comparison of Subversion with Git next to each other. We're going to talk about topic branches, what they are, why you should use them. We're going to talk about starting or contributing to GitHub projects. And then at the end of this talk, hopefully we'll have time to cover some cool Python things that deal with Git and GitHub. So that's our order of discussion today. The next slide is kind of trying to give you guys a basis for all the lingo that Git has. So Git has like its own vocabulary, and this slide tries to summarize what all those things are in one neat place. So I'm going to give this a shot. We'll see what happens. At the very top, you see there's a green box that's called History. And then there's a blue box in the middle that's called Stage. It's also sometimes called the Index. I don't know why it has two names, but it does. And then at the bottom is the working directory. And the working directory is like the directory that you're using to type things into your terminal and save files and open files and create files and stuff like that. And then what these arrows do on the, let's see, that'd be your right, those actually move you up this stack. The ones on the left, they actually move you back down the stack. So if you want to move files from history to stage, you can do git reset -- files. Or if you want to move things from stage to the working directory, you can do git checkout -- files, right? And then vice versa, you can do git add files. That will push stuff into stage, and it will not change your working directory. And you can also do a git commit, which will actually write things into the history, okay? Does everyone feel clear or comfortable with that? Okay. By the way, all these slides are available on speakerdeck.com, and the URL will be at the end of this talk. So if you want to take notes, feel free, but you don't have to. So the next slide, similar terminology, and the colors are the same. So hopefully this will help make this clear. This tries to explain what Git can do under the hood. So this goes like another level deeper into that onion of what Git can do and all of its capabilities, and also terminology. So again, at the bottom we have this kind of pinkish box that's the working directory. As you can see over here, it says files that you see. Then there's this blue box, right? Those are the stage directory. That's basically you're telling Git, hey, these are files I want you to put in history eventually, but not right now. Okay, but track them for me. And then at the top, you can see we have a whole bunch of green boxes, and they all have these weird hexadecimal tags on them. Those are the actual commits. And you can see that it moves through time. So over here, way over here on this side of the screen, that's the oldest commit in this history. And way over here on this side, that's the most recent commit, right there, ED489. And then on top of that, you can see that there's these other things. There's a little orange box that says master, and on top of that, there's this little gray box that says head. And you're thinking, well, what do those things mean? Well, basically what those two boxes are intended to be are a human-friendly way to identify a hash commit. Most of us are really bad about, well, speaking for myself, I'm really bad with numbers. I can't remember phone numbers to save my life and things like that. So I don't really want to call commit ED489 ED489. I want to call it something else, like head. I can remember head because it's easy to remember and I can type that. But I won't always remember ED489. And actually, Git allows you to assign arbitrary tags to arbitrary commits. And we're going to cover that in just a few more slides. But basically what's happening here is the working directory and the stage, and then you see a series of commits. And the commits go backwards through time. That's the main point we're trying to get across with this slide. Does everyone feel good with that part? Yes? OK. All right, cool. So this is the slide I talked about earlier. This really compares Subversion and Git side by side. You can see here I'm just doing a simple file creation, checking status, committing it to the repository. Over here is the Subversion workflow, which most of you probably are familiar with. And then over here is the Git workflow. Now you can see that there's actually more steps here with the Git side of things. And I don't know what part you fall under, but this is either a bug or a feature, depending on what interface you like. If you like lots of control and detailed control over every step in your source control, you're going to probably like this side better. If you like things to be a little bit simpler, you're probably going to like this side better. But don't fret. Don't fret. We'll talk about some ways to make Git friendlier towards the end of this talk. But basically what's happening here is we're cloning a repository. We're going to create a new file. We're going to check the status. We're going to add it to the working directory, or to the stage, sorry. We're going to do git add myfile.py, and that's going to add it to the stage directory. We're going to check it, right? We're going to do a diff against what's in the history, so what is in the current head. And then we're going to do a commit. And we're going to say my commit, and then we're going to push it. We're going to push it upstream, or push it to wherever the origin is. So what are those things? Origin? What does that mean? That's what this slide talks about. So this is the exact same workflow from the previous slide, but this time I've highlighted a couple of things here. At the very top, I have a box call out that says origin. The origin is basically where something came from. So that's basically where you got your source code from. Git stores that by default using a tag called origin. And origin is where, right? And you can assign other names. Later on, we'll talk about this. You can assign other names for other remote locations that are human-friendly. So instead of typing https example.com, I can just type git push origin, right? And that's a lot faster and simpler and easier to remember, because then I don't have to remember exactly where I got it from. I just say push it upstream, and it does. And then at the bottom, I have this blue box that says master. And you think, well, what does that mean? Well, master is the name of the branch that you're on. And by default, Git uses a branch called master. And now you say, what is a branch? A branch is basically just a version of the code that you want to work on. And in Git, you can create as many branches as you want, because they're really lightweight and easy to create and fast. How many of you have used branches with Subversion? Anyone? Yeah, how fun was that? Yeah, it's not fun at all. So everyone who used Subversion, myself included, tries to develop on a really linear timeline. So basically all you're using your history for is kind of saving your working state at some point in time. With Git, you can actually create branches that are not crazy and insane and easy to merge with your trunk in the future. So you can create as many lightweight branches as you want, make as many changes in that branch as you want, and you can either merge them or discard them or whatever you want. We're going to talk about that in a second, probably in a few minutes, maybe 10 minutes, about topic branches. And that's what topic branches are all about. So anyway, when you check something out or clone something, by default you get a branch called master, and master is just the main branch basically. You can create as many other branches on your own copy of that repository as you like, and it will not affect anyone else's versions, and it won't cause them any trouble later on if they want to merge your code with theirs. That is very much unlike Subversion. So that's a key difference to keep in mind. If you are used to Subversion, using branches on Git is a really, really good thing to do. Okay, so the next few slides that we're going to go through are really sort of cookbook type things. So they're kind of a formula of I want to and then some activity. So for example, the first slide here is I want to create a new repository. How do you do that? Well, it's really straightforward. You make a new directory, you go into the directory, and then you type git init. And that will actually initialize your directory for the first time. It'll create this directory in there called .git, and there'll be a bunch of stuff in there that you can play with if you want to, but you don't have to. Okay, next one is copy remote repository. Again, if you want to sort of keep this in your head, you can take notes, but all these slides are available for you to look at later. So this time, like I said, we're going to make a copy. Git actually has 5 or 6 different ways to pull data from somewhere else, but the 2 most popular ways are using HTTP, in this case secure HTTP, and then the other way is using SSH. So this is sort of an SSH style on the bottom, and on the top is kind of an HTTPS style. There are lots of other ways to do it. Git actually has its own data transfer protocol built into it if you want, but most people use one of these 2 ways. Next one, stage a file for commit. Git add my file. Some people ask me, why do you use a --? What does that mean? Well, Git has like 80,000 command line flags, and sometimes it has no flags at all. So if you want to be super paranoid about adding things to your stage directory, what you actually can do is send --, and that says to Git, hey, I am totally done processing command line arguments. So don't interpret anything after this as a command line argument. Always treat it as a file name. So that's what the --. is for. Do you have to use --? No, you certainly don't. But I like to because I'm kind of paranoid about it. What if you screw up? Like, what if Git interprets something wrong? Well, first of all, don't panic. The main thing to remember there is that you can always, we're going to go into this, but you can always stash your work and come back to it later. Okay. So I want to create a commit. You guys already know this one. Git commit, we talked about it. Hey, I want to add to the last commit. So this kind of plays into what we just talked about, which is, what if I make a commit and then I realize, hey, I left a debugging comment in there, and I really want to take it out because I want to push this upstream, and I don't want to have to do a whole new commit that says, I'm a dumb developer who forgot to take out his debugging. What you can do is actually change your file, and then you can do a git commit amend, and we'll actually squash that, the old commit and the new change that you made into a single commit. So that's kind of nice. It's a very handy feature. It really only works for the last commit that you made, though. There are advanced ways to change commits out of order, but we're not going to go into those today. So git commit amend is a really handy thing to have if you made a mistake with the very last commit that you made and you want to change it. Here's something that lots of people find useful to do. And this is one of the things that is really cool about having the entire history of your project. You can literally diff your file against any version that previously existed in the whole project. And one of the ways you can do that is by using the git diff command. The second and third examples here are kind of crazy Git interface. And they're either genius or crazy or both. So we have this thing called head. And if you'll remember from the very first slides that we talked about, head is like this sort of floating tag for the most recent commit that you've made. And you'll see there's like head with the little hat next to it. You're like, what does that mean? Well, what it's trying to say is, I want the head's ancestor. So I want its first ancestor, which would be its grandparent commit, right? That's what that, you can keep putting on more hats if you want to go up in generations. Now, if you want to do like the 10th ancestor of head, you would have to have 10 hats behind head. And that's really, really kind of silly. So they have this shorthand version, which is the tilde and then some number, some integer that's greater than 1 or 0, I mean. So you can do head tilde 10, and that would get you the 10th ancestor of head, and it would diff your file against that. Now, if you don't want to do that, you can do this version here at the bottom, which is like, I want to diff this against any arbitrary commit that's in my history. So that's what this is. So at any point in time in history, I want to check my file against that commit and this file right here, and that's what you'll get. You'll notice in the top examples, I don't use any file names. So you can assume that what's going to happen, and this is actually what happens, that Git's going to diff your directory against the directory that it has in its history. So it will diff every file that it knows about and compare it to whatever you ask it to compare it to. But if you ask for a specific file, it will do only that specific file. Okay. Git log. Lots of you have probably used SVN log or something like it. Git has its own logging facility. It's super powerful. It's ridiculously configurable. That's also a feature or a bug, depending on what your point of view is. It's really great to be able to look at graphs in a really shorthand way. So you can actually make Git print out a nice little ASCII digraph of the commit history of your project or the project you're working on. And that's pretty useful usually, because you can kind of track where branches got split off, who worked on them, what tags they have on them, and how they got merged back into the main branch. That can be really useful for tracking down bugs or trying to find features or blame people for really shoddy work or congratulate them for really awesome work, although that doesn't happen too often, unfortunately. The next slide is really handy. So let's say that you've cloned a repository and you want to pull down all the changes from upstream. You can do that using git pull. That will pull down all the changes and automatically merge them onto yours, even if it is dirty. If your working branch has work in progress, you can actually do git pull, and it will safely update your branch for you, or warn you that it cannot safely update your branch. So then you can decide what you want to do then. That's pretty cool. Git tag. Earlier we talked about how you might want to have some arbitrary name pointing to any commit. This is how you would do it. One thing that is really strange about Git, well, not just one thing, but one of the many things that is strange about Git is that tags are not automatically pushed with the rest of your commits. So a tag is actually a commit. It's a commit object. So it's a first-class commit, but it's not pushed with the rest of your history unless you explicitly tell git push to send it. So if you create tags and you want to share those tags with other people, then you have to do git push -- tags. Otherwise, they're only going to be on your local box, and that's not always great. When we talk about how GitHub treats tags, we'll go into why you probably want to share them with people. Now, the cool thing is once you create a tag, you can use that tag anywhere that you might use a commit. So remember, earlier we had this thing where you do git diff and then some hex number. Now you can do git diff my tag, and you can do a file name, and it will do the same thing, which is pretty cool. So like, let's say you're going to chop off, you're going to say, at this point in my commit history, we're going to do the 1.0 release. You could tag it as 1.0, and then if you wanted to diff things against 1.0 and 1.1, you'd have a really easy way to do that without having to remember a ridiculously long hex number. Excuse me. All right, we talked about upstream and origin. So this is the explicit way of adding an origin. You can actually name that whatever you want. It does not have to be origin. You could call it Bob. You could call it upstream. You could call it Fred. You could call it Sally. You could call it whatever you want. There's also the way to remove it. So you can add and remove those, and that's handy, especially if you use branches. We'll talk about that in a few minutes. Git push. So I want to push my local work to a remote repository. I have two forms on the screen. The top one you guys have already seen like 85 times, so hopefully it's familiar. The bottom one uses this -u thing. What does that mean? Well, -u, really what it does is it sets up your local origin to track whatever you push to. So what you're saying is, I want to push it to the origin, and I want to track that origin as well. So if you don't give it -u, what's going to happen is your local origin is going to be empty, and then you're not going to be able to do things like git push without having a whole bunch of stuff behind it. So this is a really handy thing when you initialize a repository from something that already exists. Okay? Now I know that sounds confusing, but when we talk about the GitHub part of this, maybe that will be more clear. All right, this is my favorite thing about Git, without question. I'm going to share it right now. This is very cool. So let's say you're working on something. You're working on, I don't know, whatever, and your boss comes to you and says, hey, we really need to fix this bug, this high-priority bug, and it's in version 3.4, and you're working on head, right? So you're working on the most recent version of the code, and you're like, man, I'm halfway through editing this file. I'm like almost done implementing this new feature, fixing this bug in the head, and I really don't want to have to switch my whole thing just to do this. But what you can do is Git lets you stash things. And a stash is like a snapshot of your current working directory. It pushes it into an anonymous commit with no commit message, and it tells you that it's on a stack now. So stash uses a stack, and you can stash things. You can stash as many things as you want, but they won't actually be part of your tree until you unpop them and then actually commit them for real using git commit. So a stash is like a work in progress commit, which is super cool. So you can stash your work in progress. You can check out the branch of the bug stuff that you're supposed to work on, do it, fix it, commit it, push it, and then pop your old work off, and you'll be right back where you left. Everything in your working directory will be restored to the way that it was when you made the stash, which is super cool. Super cool. It's my absolute favorite thing about Git. Okay, so we just went through like 20 different slides about Git commands, what they do, how they're cool, why they're useful. The key thing to remember here is that they're usually scripts. So if you actually look at Git itself, the C parts of it are actually really, really small, and most of the rest of it is glued together with Bash and Perl and Python. And what that means is that everyone in this room should feel really comfortable with creating your own Git commands. That's kind of a neat idea. So you can extend Git to do things that you want it to do, even if the people that developed it think that's crazy or it doesn't work on your workflow. So that's pretty awesome. And we're going to talk about some of the ways that you can interface with Git using Python at the end of the talk. All right, so we've got topic branches. Oh, wait. Before I start with topic branches, are there any questions to this point?
And is the last commit that you did or the last commit that everyone did?
It's the last commit that's the last commit in the history. So if you just cloned a repository, head is going to be the last commit that you pulled. If you made your own local commit, then that's going to be head. Does that make sense? So when you get it from the remote, head is whatever the last commit was upstream on the remote system. And then if you make your own local head, that's what it would be. Okay? Anyone else? Right. Everyone has their own. Everyone has their own head, but the name is the same. But it may point to a different commit. So my head would be different than yours, or vice versa, and that's fine. It won't screw any of us up, and it won't make Git messed up either, because of the way that it does merges. Are there any other questions?
I just want to mention, you should probably say stash per branch, right? So you should say stash per branch.
Yeah. So when I said that you can stash whatever you're working on, what I really should have said is per branch you can stash that. And I know that probably doesn't make any sense to you right now, but basically what it means is that if you're in branch A, you have to stash branch A before you can go to branch B. So that's basically what I should have said. So now we're going to talk about topic branches. We've talked about branches a couple of times now. We're going to talk about what they are, why are they useful, and how do you use them. And we're going to get into that right now. So this is going to be just a little bit more Git command here. So let's say that you have a ticketing system in your company. At my company, we use something like Git issues, but it's not Git issues. Anyway, it assigns these numbers like RT14322 or whatever. And so what you want to do is say, I'm going to close that bug, right? I'm going to look at that bug report. I'm going to open it. I'm going to create a new branch of my project, and then I'm going to go ahead and create this new branch called 14322, because that's the ticket I'm working on. And I want to kind of track all the work for that ticket in this branch, right? Remember earlier I said branches are super lightweight. They're easy to use. They're easy to merge. So this is a nice way to kind of quantify the amount of work that you do on a specific topic. And this is where the concept of topic branches comes from. So what we're going to do is tell Git, I want to make a branch called this, and then I want you to actually populate my working directory with that branch. That's what branch means, create a branch. And then there's checkout, which means populate my branch with those files in my working directory. And then at the bottom, there's like the shortened form of this, which is git checkout -b and then the branch name. So if you don't like typing all that stuff, you can do git checkout -b, and then you can put the branch name at the end, and it will go ahead and do both steps at the same time. So let's say you hack away, you get done with your RT ticket, you're ready to go ahead and close it. What do you do then? Well, first you need to commit all the files in your branch, right? So let's say your branch is totally clean, you don't have any dirty files in your working directory. What you tell Git is, I want to switch to the master branch, git checkout master. That means I want to move from the branch I'm on back to the master branch. And then I want to do a merge, right? So I want to do git merge and then the branch name. And what Git will do is it will look at the branch that you have, look at the stage files that are in that branch, and it will say, how do I put these two things together? How do I put these two things together in a way that's safe and won't cause any conflicts, if possible? And it will go ahead and do that. And that's how you do branches and merging branches between Git. And this doesn't have to be master. It could be any two branches you want. And it can actually be more than, I don't want to confuse you guys, but let's suffice it to say that merging and branching is very complex, but this is the most straightforward and common workflow, which is I want to create a topic branch for some topic. Like let's say I want to create a new feature, or I want to work on a bug ticket or something, and then you want to merge that work back into your master branch. This is how you would accomplish that. Are there any questions about topic branches or merging stuff? No? Okay. All right. So now we're going to talk about GitHub. Does anyone know what this thing is? It's an Octocat. Yes. Who said that? You win a no prize. Congratulations. This is an Octocat. It's the mascot of GitHub. Why is it the mascot of GitHub? I don't know. Well, yeah, Git has a strategy called octo merging, so that probably plays into it. But as far as the kawaii little cat creature and the little octopus arms, I don't know. Whatever, it's fine. So the first thing you need to know about GitHub is that to really participate in GitHub, you're going to need an account. So you say, well, how much does an account cost? As long as you're working on open source projects or free software, it doesn't cost anything. The only time you have to pay them is if you want to keep your repositories private. Now, at my work, we do have a private GitHub, and it's worth every penny. But for most people that are just doing development work, as Python enthusiasts, most of that's open source work. So you can sign up for a free account, and it's really straightforward. It's, name and email address and password. It's free. There's the URL if you want to sign up. By the way, I'm not getting paid anything here or whatever. Yeah, in case you were wondering. I just like the service and use it frequently at work as well as in my own personal side projects. So this is my personal GitHub page. That photo is different now, but I'm a very handsome person. There really wasn't enough laughter. But anyway, new repository, that's the key thing here. That's why there's a big green arrow. You guys are going to see lots of big green arrows and big yellow arrows over the next few slides. What those are intended to do is direct your attention to that specific line or that specific button. In this case, what we want to do is create a new repository. So let's pretend that I'm creating a new Python project that I want to share with people on GitHub. What I'm going to do is I'm going to press that new repository button. It's going to take me to this page here where I get to define what my repository is going to be called, what the description is, if it's public or private, should Git pre-initialize mine or not. I said no because I already have stuff to push in there. And then over here you're going to push this create repository button. It's friendly and green. We all like friendly green things. Press that button and you're going to get this page right here. Create a new repository in the command line. So there's a whole bunch of Git commands in this screenshot, but all this stuff is stuff that we've talked about already, so everyone should feel really familiar with it. The only thing that I want to point out to you is the git push -u origin master. If you look kind of in the middle of the page over here, you're going to see that, and we already talked about what that does. That sets up your local origin to track the remote GitHub repository, which is probably a convenience that you want to have. All right, so here's a terminal session. I did not type this morning, by the way, so yeah, done in advance, I promise. So we're initializing our repository. you can see that it responds, initialize empty Git repository and user Malin blah, blah, blah. That's nice. Then we're going to do git add. It's going to add all the files in my current directory, including all of its subdirectories, so it is recursive. If you have a whole bunch of directories, it's going to add those. Now, one thing that I will warn you about, Git does not save directories by default. SVN will save empty directories, just if you tell it to. Git will not. If a directory does not have any files in it at all, Git will ignore it. So if you want to have a directory that's empty, quote unquote, you need to go into that directory and put some kind of dot file or something else so that it has a placeholder that Git can identify and tag and store in its history. If it's empty, it will not store it. And that can be a source of confusion, but that's just the way the software works. So it's also not likely to change. So complaining about it really isn't going to be helpful to the people that write Git. So git add dot, that saves all the files in the directory. You guys know this. Git commit -m. -m stolen straight out of SVN. It means here's my message, right? Don't start my editor. I skipped over a whole bunch of junk, which actually I want to talk about really quick. You can see that it says master root commit, and then there's this hex number. You guys all know what that is. That's the commit number, right? The commit identifier. Initial commit, 6 files changed, 185 insertions. There's all the files in this directory, by the way. This project is on GitHub, and if you want to play around with the project, fork your own, send me pull requests, whatever, feel free. That's totally cool. So then we have the git push. We're going to add the origin. Remember, we talked about how you add origins. And then, actually have 2 pointers here. We're going to add the origin, and then we're going to push it. You guys have seen that before. And then you'll see that it's counting objects, 9, done. Right? We're just kind of scrolling down the screen. It's compressing things, compressing. And then here it goes to git, GitHub, Malin, py-silly-walks.git, and then it says new branch, master, arrow, master. What is this arrow thing? Well, this is my local name, and this is what GitHub's name is. So it is possible for you to have names that are different, but I really don't recommend it. It's super confusing. Try to track your remote names as much as possible, because otherwise you'll be very confused unless you're smarter than I am. Well, you probably are smarter than I am. Anyway, I just recommend that you keep your names the same, because otherwise it is really confusing, and it will be really confusing to anyone who comes after you. Here's what I wanted to show next is, okay, so I've committed this stuff. I pushed it upstream to GitHub. What I want to do now is I actually want to add some stuff to my project. So what I noticed was when I was doing git status to find out what the status of my working directory was, that there was a bunch of stuff in there that I don't want it to show up. So Git has this thing called .gitignore, and that will actually create a set of rules to tell Git to ignore certain files. So let's say that you have, like I use VI, or Vim, and when VI is open, when Vim is open, it creates these swap files. If you don't want Git to track those swap files, because they actually physically exist on your disk, then you can tell in the .gitignore, I don't want you to track .swp files, and it will ignore them. Same thing for dsstore, like in OS 10. The Finder creates a whole bunch of these junk files called .dsstore that are supposed to save like window positioning and junk like that. Those show up in Git status. So if you don't want those to show up in your Git status things, you can put those in there. It's just a really handy thing to do. And I wanted it to be part of my project so that I when I clone it on other systems, it'll just be there. I don't have to type it again. So I do a git add .gitignore. Ignore swap files and other stuff, and I push that in there, and you can see that. And then on the next slide, we're going to tag this. Whoops. Getting out of order. What I'm trying to do here is show you that GitHub, when you start a project, actually tells you what you need to do to get started. All the commands that I just typed are exactly the same as what's up here, right here. It's exactly the same. I mean, the only thing that's really different is me choosing what files to edit and what files to add to my repository. That's really the only difference. Okay, so now we're going to talk about tags again. So here we have git tag -am, some string, right? That's my message. And then we have the version number. We have 0.01. And then we have some commit, whatever, FAD5AA5. All right. We talked about this already. What that's saying is I want to refer to that commit as that number. So whenever I use that number on the command line, refer to that reference, to that hash. I'm going to push it. And you guys remember we talked about -u? If you don't use -u, you will never see what's in that red callout box up there. Branch master set track remote branch master from origin. That sounds like a bunch of gobbledygook, but since we've talked about all the Git terminology, hopefully that makes sense. Does that make sense to everyone? Are there any questions to this point? Question? No? Okay. So what happens on GitHub when you use tags? Actually, something really cool happens, and this is why I highly recommend you use them. When you create a tag in GitHub, it actually creates a snapshot of your directory with that tag name and packages it as a tarball or a zip file. So what that means is that someone who's working with you that doesn't use Git or doesn't want to use Git can grab your source code at some certain point in time and start working on this project with you. So that's super handy. Also, if you want to submit, I don't know, packages of your source code to someone else or to some external party, you can do that right here. And it's super convenient because it's already packaged at that point in time with that tag name. So it's a really nice way to keep track of versions of your software, releases of your software. It's pretty nice. All right. So, excuse me. So the next thing we're going to talk about is forking. Forking basically means I want to take a copy of your repository and clone it over into my own personal little area within GitHub. So I want to take a copy from user X and I'll make it my own. And then I'll have my own little playground to work on user X's software. So you press this fork button and you get your own little copy. You can see up here I have a demo account from OSCON 2012 demo. And now OSCON 2012 demo, which is just another user account on GitHub, has their own copy of this repository. And then they could do whatever they want. They could delete it all, or they could enhance it, or make it better. But the point here is to show you that what we really want to do is add a new feature to this, or do a pull request. So that's the point of this whole next part of the talk. So the first thing we need to do is clone it. And you'll notice we're cloning from the OSCON demo repository. We're going to create a feature branch, right? Git checkout -b. We talked about that already. And then finally, we're going to go ahead and do some editing. You can set gvim, and then I do blah, blah, blah. And then I'm going to implement an action generator and a step function. And then I push it. And here you'll say, well, I thought you said you could just type git push and it would push it. Well, that's true, but in this case, I want to do something different, which is I want to create a new branch on GitHub. So I need to tell Git that I'm going to push this branch, feature/step, to the origin, because otherwise it'll try to push master, and master has not changed. So there we go. And on GitHub's interface, it has this pull-down menu thing here, where it says branch master, and then you can see that there's my new branch, feature step. So we're going to pick that. We're going to select it. That's what I'm pointing out in the green arrow. And you'll see that the time has changed. Let me do that again. So you see that Silly Walks is the directory there. The time, if you look kind of in the middle of the screen, right here, this is what I'm talking about, right there. It says a day ago, right? Because that's what I am on the master branch. But when I switch to the new branch, it's 5 minutes ago because I just made that change. Well, 2 days ago I just made that change. But 5 minutes ago from the time I took the screenshot, and then we're going to submit a pull request. And that's what you would press. What that means is I want to send my changes to the person that owns this software. So you get this nice screen. It says, you can talk about your commit and say, hey, I like your software, but I really needed to have a step generator. So I wrote this, and it has tests, and it's awesome, and you should totally merge it. You press the send pull request button, and what happens is it goes into the person that owns that directory, owns that project. So wherever you cloned it from, wherever you forked it from, will be able to merge your changes directly into their source control using this mechanism. And they can also review your diff. So you'll notice that the URL is the Moralen one. It's not the demo account. And then here's the diff that I talked about. So this is all the changes that were made as part of the OSCON demo user. So that's what you have to do to submit your pull requests. Sometimes when I do this talk, people say, my module is in CVS or SVN. First of all, I'm very sorry for that. You have my sympathy. But the nice thing is that Git actually has some really nice tools to help you move that stuff into Git. So as long as you have a really linear commit path, moving to Git is really straightforward. But we're not going to talk about that stuff today. Maybe in part 2 of this talk. All right, so I have about 3 minutes left, and we'll talk about cool Python stuff for the next few minutes. Are there any questions? Any questions about pull requests or GitHub or anything like that? Okay, so there's actually several cool things. There's two slides of cool things about Python and Git. First is this project called Dulwich. Git, as you may or may not know, is actually implemented all in C. It's written as a whole bunch of tiny little C programs. But there's another project called Dulwich, which is a pure Python Git implementation. So it's the same protocol, but it's actually really straightforward as far as having a pure Python implementation. So if you don't want to deal with C, you don't want to deal with programming C, and you're comfortable with a little bit slower execution time, check out Dulwich. There's also GitPython. GitPython takes the Git interface and wraps it in a Python library. So if you need a programmatic way to interact with Git libraries, that's a really good option. There's also one called Legit, which is by Kenneth Reitz. You may know him as a guy who did requests, and he's written a whole bunch of other kind of really nice libraries for Python that kind of replace things that have silly APIs with things that have less silly APIs. So that's a really nice project to check out. There's also a Python binding for PyGit2. PyGit2 is an alternate C implementation. So Git was created like in 2005. At this point, it's about 7 years old. And there's just kind of a lot of cruft in the C implementation. So Git2 or libgit2 was this not fork, but basically it was a group of developers that wanted to rewrite the internals of Git in a really rational way with a nice API. And so what they did is they wrote this thing called libgit2, which interacts with Git repositories but does not use the original code base. And then finally, if you like Qt interfaces and you're also like Python, and hopefully you like Python because you're here at this thing, then you can check out Gitcola, which is kind of a Qt interface for Git with Python. It's written in Python, so that's pretty cool. Are there any questions about any of these projects or anything that I can tell you about any of them? No? Okay. That's it. Thank you for your attention, and really appreciate it. Thank you. Yeah, so the slides are there at that URL, and they're available now. So if there's one thing you write down and you want to look at the slide deck later, that's what you should write. All right. Are there any questions now or anything?
What if you want to, if you don't trust GitHub as far as losing your work, how would you make a local backup and also verify that by uploading to GitHub instead of doing a project? You want to make sure you have your whole history. If GitHub goes down, you actually need to restart.
Okay, yeah, Git actually has a server mode that you can start where you can do it on your own local repository, and it will process commands. The way you interact with it is almost the same, but you have to change your origins and your poll strings and stuff like that. But it's totally doable to do that. As far as setting that up, I mean, that's a little bit out of the scope of the talk, but it's not too hard. There's actually several tutorials that can walk you through how to do that. If you want to have your own local Git copy and then upload it somewhere. Yeah. What's that? Okay. Okay. So Dropbox, Google Bear, those are some of the suggestions for people that are on the video and can't hear the question. By the way, the question was, how do you set up your own local copy of Git as a server? Are there any other questions I can answer? All right. Thank you very much. I appreciate your attention today. Thanks.